This is a video from section 3.6, the directions say to differentiate the function. And we're going to go ahead and start with number 17. So 17 says t of z equals 2 to the z times log base 2 of z. Now, I'm going to rewrite t of z as the following. I'm going to write it as 2 to the z times natural log of z divided by natural log of 2. So I did a change of base. And so this is 1 over natural log of 2 times 2 to the z times natural log of z. And I'm going to now apply the product rule. So t prime of z is 1 divided by natural log of 2 times the quantity. Now, I'm going to write down the first function, which is 2 to the z, and I'm going to multiply by the derivative of the second function with respect to z. The derivative of natural log of z is 1 over z. And then I'm going to add natural log of z times the derivative of 2 to the z, and 2 to the z is the first function. So we're going to differentiate 2 to the z with respect to z, which is 2 to the z times natural log of 2, like so. Now, what I notice is there's a 2 to the z that's common to both terms, right? And so I'm going to pull that out. And so I get 2 to the z over natural log of 2 times the quantity 1 over z plus natural log of 2 times natural log of z. And I would always double check with your instructor in terms of if your instructor wants you to get a common denominator or what have you. If you decide to get a common denominator, it'll look something like this. It'll be 2 to the z over natural log of 2 times the quantity 1 plus z natural log of 2 times natural log of z, all divided by z. So it would look something like that. And that is number 17. Let's take a look at 21. Now, on 21, we have y equals natural log of e to the negative x plus xe to the negative x. And I want to find dy dx. So I'm going to apply the chain rule. So this is 1 over e to the negative x plus xe to the negative x. And I'm going to take that and multiply by the derivative of e to the negative x plus xe to the negative x with respect to x. So I get 1 over e to the negative x plus xe to the negative x. And I'm going to take that and multiply by, now the derivative of e to the negative x is negative e to the negative x. And I'm going to go plus, and then to take the derivative of xe to the negative x, I have to apply the product rule. And so I'm going to write down the x, that's the first function. I'm going to multiply by the derivative of the second function, e to the negative x, with respect to x. But we've already done that, and you get negative e to the negative x. And then I'm going to add the second function, which is e to the negative x, times the derivative of the first function, which is 1. Now, by the way, when you take the derivative of e to the negative x with respect to x, you're applying the chain rule. That's just chain rule. The inside function would be something like f of x equals negative x. And the derivative of the inside function would be negative 1. And that's where I'm getting the negative there. That's why it's negative e to the negative x. And so these terms cancel. And what we end up getting is, we'll write this in black here, dy dx is negative x e to the negative x divided by e to the negative x plus x e to the negative x. But I can write this as negative x e to the negative x divided by e to the negative x times 1 plus x. But if you notice, these e to the negative x terms, factors I should say, cancel. And so therefore, dy dx is negative x over 1 plus x. And that's how you do problem 21. If we take a look at 23, suppose h of x is e to the x squared plus natural log of x. Now, again, this is chain rule. So I'm going to write this as follows. H prime of x is e to the x squared plus natural log of x, but I'm going to multiply by the derivative of x squared plus natural log of x with respect to x. And so this is e to the x squared plus natural log of x times 2x plus 1 over x. The derivative of x squared is 2x. The derivative of natural log of x is 1 over x. Now, if we get a common denominator, we get e to the x squared plus natural log of x times 2x squared plus 1 divided by x. And I can do something with e to the x squared plus ln of x. So I can write this as h prime of x is e to the x squared times e to the natural log of x times 2x squared plus 1 divided by x. And by context, x is greater than 0, right? And so this is e to the x squared times e to the natural log of x is x times 2x squared plus 1 divided by x. These x's cancel, and we get e to the x squared times 2x squared plus 1. And that's h prime of x. That's number 23. If we take a look at 25. So on problem 25, we have y equals natural log of x to the a divided by b to the x. And so I'm going to rewrite this as natural log of x to the a minus natural log of b to the x. And so therefore, by properties of logs, again, we can pull the a out in front of the log and write this as a times natural log of x minus, and if I pull the x out in front, I'm going to subtract x times natural log of b. A and b are constant, and so if b is constant, natural log of b is constant. And so if I want dy dx, I'm going to get a times 1 over x minus natural log of b times 1. And so therefore, dy dx, if I get a common denominator, I'll get a minus x times natural log of b divided by x. And that's what it would look like if you get a common denominator. That's 25. Let's take a look at 27. And 27 says to show that the derivative of natural log of x plus the square root of x squared plus 1 with respect to x is 1 divided by the square root of x squared plus 1. So we're going to start with the derivative of natural log of x plus the square root of x squared plus 1 with respect to x. And we're going to apply the chain rule. So this is 1 over x plus the square root of x squared plus 1 times, okay, so we're going to multiply by the derivative with respect to x of that inside function, which in this case is the derivative of x plus the square root of x squared plus 1. So again, we get 1 over x plus the square root of x squared plus 1 times the derivative of x plus the square root of x squared plus 1 with respect to x. So this is 1 over x plus the square root of x squared plus 1. And I'm going to multiply by the derivative of x plus x squared plus 1 to the 1/2. And now I'm ready. So this is 1 over x plus the square root of x squared plus 1 times 1 plus, now the derivative of x is 1 with respect to x. The derivative of this second term is 1/2 of x squared plus 1 to the negative 1/2 times the derivative of the inside function, and the derivative of the inside function is 2x. But the 2's cancel, and we get 1 over x plus the square root of x squared plus 1, and we're going to multiply by 1 plus x over x squared plus 1 to the 1/2, like this. Now, I need to get a common denominator. And the common denominator is x squared plus 1 to the 1/2, or the square root of x squared plus 1. So let's do this first. And we get 1 over x plus the square root of x squared plus 1 times 1 plus x over the square root of x squared plus 1. Now, we need to get a common denominator. If it looks like you need to get a common denominator, you need to get a common denominator. And so I'm going to rewrite this as 1 over x plus the square root of x squared plus 1 times the square root of x squared plus 1 plus x divided by the square root of x squared plus 1. But if you notice, x plus square root of x squared plus 1 will cancel this x plus the square root of x squared plus 1. And what we have left is 1 over the square root of x squared plus 1, which is exactly what we wanted to get. And so therefore, the derivative of natural log of x plus the square root of x squared plus 1 with respect to x is the same as 1 over the square root of x squared plus 1. And that's how you prove 27. It's a bit intense. It involves the chain rule. So, yeah, that's problem 27. What I want to do now is I want to take a look at problem 37. Suppose f of x is the same as natural log of x plus the natural log of x. And we want to find f prime of 1. And so, first off, we need to take the derivative. Again, this is a clear application of the chain rule. The inside function is x plus the natural log of x. It's the argument of the natural log. And remember that the natural log is the outside function, right? Now, so f prime of x is 1 over x plus the natural log of x times the derivative of the inside function, which is 1 plus 1 over x. Okay. Now, what I would do is just plug in x equal 1 directly. And so we get 1 over 1 plus natural log of 1. And we're going to take that and multiply by 1 plus 1 over 1. I'm just replacing x with 1. Natural log of 1 is 0. And so what this tells me is f prime of 1 is equal to 2. That's problem 37. I want to finish with problem 39. It says, find an equation of the tangent line to y equals natural log of x squared minus 3x plus 1 at the point (3, 0). Okay, and remember, when we want to find the equation of the tangent line, we need to find the slope of the tangent line at the point 3, 0. And so what do I need to find the slope of the tangent line? I need to find dy dx. So dy dx is 1 over x squared minus 3x plus 1 times, right? the derivative of the inside function, which in this case is the derivative of x squared minus 3x plus 1 with respect to x. Okay. And so, therefore, dy dx is 2x minus 3 divided by, right? The derivative of x squared is 2x. The derivative of 3x is 3. So you get 2x minus 3 in the numerator. And we're dividing by x squared minus 3x plus 1, like so. Now, dy dx, evaluated at the point 3, 0, is 2 times 3 minus 3 divided by 3 squared minus 3 times 3 plus 1, which is equal to 3 divided by 1, which is 3. So we're given slope 3 and point 3, 0. Okay? And to get the tangent line, we do the following. Remember that y equals mx plus b, but the slope is 3. So y equals 3x plus b. When x is 3, y is 0, and so 0 equals 3 times 3 plus b. So b is negative 9. That's it. And so therefore, y equals 3x minus 9. And this is the equation of the tangent line. And that'll conclude this video for section 3.6. We worked on problems 17, 21, 23, 25, 27, 37, and 39. Thank you.